Okay, this is chapter 3, sequences and series. These are roughly sort of the sections that we're going to look at, and we're going to start by looking at what are called arithmetic sequences, these ones here. So this is an arithmetic sequence. You can tell it's an arithmetic sequence because it has a common difference. Common meaning that it's shared, difference meaning that you are adding or subtracting. Okay, we can find out a lot of stuff and we can do a lot of stuff based on a few things. Based on the first term, which we normally call A. Based on this, because it's the difference, we call this one D. And based on the position of the term. So for example, because this is the fifth term, this would be sort of the n equals 5 term. So the letters that we're interested in are going to be A, N, and D. A little bit more jargon for you. So this sort of means the nth term. It means the general term. Okay, so like a rule that will always work the thing out. N, as we said, means the position. Okay, and just a little bit more jargon for you here. So the 8 here you would say is the third term, n equals 3. And another way of writing that is the third term is 8. So if we think of this in algebra, we can come up with some general rules. So the first term we said is called A. Well, how do you get the second term? You take that and then you add on the difference one time. In fact, I'm going to put a 1 there so you can see what's going on a little bit. How do you get to the next one? Well, you add the difference one more time. And there's a relationship between the position and the number of differences. Again, the position and the number of differences. So the rule can actually be written like this. It always has an A part, and then there is always one less difference. Okay, and you can see that above. So in the second term, there's one difference. The third term, there's 2 differences. Okay, so this is the rule that we use. So if you want to work out any term, so the nth term really is a bit like saying any term. Just tell me the first term. Tell me what it starts with. Tell me what position you would like in the sequence, and then I'll do that, and I'll take away 1. And I'll have that many differences, okay? That many common differences. So let's put it into practice. So the nth term of an arithmetic sequence is this. So if you tell it an n value, it will tell you the term. What are the first 3 terms? Well, that means when n is 1, when n is 2, when n is 3. So you just substitute them in. 55, take away 2 times 1 is 53. If you put n is 2 in, you'll get 2 times 2, you'll get 4. So you get 51 and you'll get 49. Okay? And it will do something like this. Find the first term in the sequence that is negative. So how would we do this if we wanted to find the first negative term? And I do not want to write them all out. Okay, that's not a good use of time. Well, negative means less than 0, doesn't it? So negative could be something like that. Okay, so I'm going to say when is the nth term less than 0? Well, state the formula, substitute in the values. So the first term is 53, because I just worked that out. N, that's what you're trying to find. So which position is the first negative one? So you don't know that. What's the difference? The difference is actually -2. Make sure you put the minus there. Super common mistake, that one there, not including negatives. And then I'm just going to solve this one. So 0, 53, you could expand it out. So you get minus 2n plus 2. And you just sort of solve this one. So if you simplify that to 55, if you say move the 2n to the side, so 2n is greater than 55, n is greater than, that will be 27.5. So you can't have fractions, okay, because positions have to be whole numbers. So the 28th term will be the first term that is not a negative number. Second example here, find the nth term. So how do you find the nth term? Well, you write out what the a is. The n, you don't know n because that's what nth term means. It means write it as a general way. And the difference, and then you put them into the formula. So there's a. What's the difference? How much is it going up in? It's going up in 14s. So for the first one, you could say that it is 6 plus n minus 1 times 14. That's the nth term. Okay? I suppose if you wanted to, you could expand that out. So you could do 6 plus 14n minus 14. Yeah. And then what's that going to turn into? That's going to turn into 14n minus 8 as a final answer. Okay. Let's do one for the other one. So again, there's the a value. What's the d value? Well, it's going down in 7s. So you would do a is 101 plus n minus 1 times minus 7. And you just expand it out and so on. Okay, something like that. Let's do a little bit more like exam favourite. So the top one really here, this is like a bread and butter question that you'd be asked all the time. So we've got a rule here, some arithmetic rule, where we have to find some numbers. The third term is 5, the eighth term is 20. A few ways you could do this. One of them is by using the nth term rule straight away. So the nth term rule was like this. So you could substitute in. And if you do that, you'll get the third term. The third term, remember, is 5 because they're telling you it's 5. The third term is a, so you don't know a yet. N minus 1, well, if it's the third term, the n minus 1 term is 2. So 2d. And that's all you've got, okay? So 5 equals a plus 2d. If we do the same for the other one, for the eighth term will be a plus 8 minus 1 is 7, 7d. So you could say that 20 is equal to a plus 7d. It is the same a in both questions, and it is the same d in both questions because it's the same sequence. So if you do 20... take away 5. In other words, if you do equation number 1, take away equation 2. Oh, sorry, the other way around. 2 take away 1. You would get something like this. So 20 minus 5 is 15. A minus a cancels out. 7d take away 2d is 5d. In other words, the difference is 3. And if you know the difference is 3, you can now substitute that back in to find out missing terms. I'll show you another way you could have done it then. So when there's not that many terms, you can sort of write it out. So the first term, the second term, the third term is 5. Fourth, fifth, sixth, seventh, eighth is 20. So how would you get from one term to the other? Well, you add on the difference. 1, 2, 3, 4, 5. So 5 differences is 15. So that's another way that you could have done it. Okay. When you know that the difference is 3, well, if you want to go backwards, then you should be taking away 3. So 5 take away 3 is 2. 2 take away 3 is minus 1. So what we would normally call the A section is minus 1. We're going to substitute these now into the nth term. So the nth term is A, so minus 1, plus n minus 1 times the difference, which is 3. If I multiply that out, I will get the following, which can be turned into 3n minus 4. Okay, so the A value is 3. A bit off-putting here that they use A and B, a little bit confusing. And the B value, what they're calling the B value here, is minus 4. Okay, Very, very common question, that one. So you should make sure you're very, very good at that one. The other one here, this is also quite a common one. So we've got minus 8, comma, x squared and 17x, and they are the first three terms. So they look like this. Well, what did we just say? We just said that an arithmetic term is when you add some difference to get from one to the other. So how can you describe this? Well, you could say that minus 8 plus d should be equal to x squared then. And also, x squared plus d should be equal to 17x. So you've got simultaneous equations, essentially, here that you kind of need to solve. So there's other ways you could have set these up. But what I would do now is I would add 8 to that side there. I will take away x squared there. And I'm going to set these equal to each other. So is that the way I would have done it? 17x. Yeah, I suppose so. For which values? So it suggests there's going to be more than one answer. So I could do x squared plus 8 is equal to 17x minus x squared. I'm going to do it a different way though, because this isn't the way I normally do it and it hasn't worked out very nicely. So the way I normally recommend that people answer these questions is they say that 17x minus x squared. So you say the difference between the third and the second term should be equal to the difference between the second term and the first term. Okay, that's just how I would normally set the question up. Okay, x squared minus 8. Okay, and you see you get the same result. So move this to the right hand side, move this to the right hand side. What would you get? You would get 2x squared minus 17x plus 8 equals 0. And you would solve that. And the interesting thing is that you will often find that there are, in fact, values. There's more than one x value that makes this thing work. Again, this is a pretty common question that you should learn to answer. Right, so that kind of completes the section then of working with the nth term.